Let's have a look at the scientific method and what marks quality in research. While the scientific method is a standardized set of techniques for building scientific knowledge, it's about the questions how to make valid observations, how to interpret results, and how to generalize these results. So when you apply the scientific method, the aims are to independently and impartially test pre-existing theories and prior findings for advancing the state of knowledge, for contributing to the state of knowledge. You want to open up new debates, and you want to suggest modifications and enhancements to existing debates. And when I talk about debates, think about scientific writing and science in general as a conversation among scholars. And there you want to open debates or suggest modifications and enhancement of the debates. So the key characteristics of the scientific methods are the form you see here. It should be logical. Scientific inference must be based on logical principles of reasoning. Confirmable. Inferences derived must match with observed evidence. Repeatable. Other scientists should be able to independently replicate or repeat a scientific study and obtain similar, if not even identical, results. And it should be scrutinizable. The procedures used and the inferences derived must withstand critical scrutiny, for example, in a peer review process at a conference or at a journal, by other scientists. This is how Buttigieg 2012, Chapter 1 characterizes the scientific method. Now with this we move on to some exemplary quality criteria. This is not a comprehensive list of quality criteria, there are many others, but these are important ones cited by many different authors. One such criteria is logical consistency. So if you don't have consistency among the concepts, propositions, contracts, hypotheses, boundary conditions and so on, think about all the different elements which make for a scientific theory. If they are not logically consistent internally within the theory, then something must be wrong. Then that's not high quality. A rather unrelated characteristic is the explanatory power. It's a question how much does a given theory explain about the natural phenomena which it aims to explain. Specifically the what, how and when of these natural phenomena. And if the theory is able to explain these natural phenomena well, then that is a sign of a high-quality theory. The next criterion is falsifiability. A theory must be potentially disprovable. That goes back to Karl Popper's philosophy of science, putting falsifiability as one of the key criteria, as we are never really truly able to prove the validity, the correctness, the truth of a theory, but we can only falsify it. And it stands as long as it's not falsified. So falsifiability, being able to in general falsify a theory, is an important quality criterion. This doesn't mean that the theory is false, only that potentially there's a way, a scientific method, which we could find out whether it's false or not. Then there's parsimony. I mean, you can increase explanatory power of a theory if you put in more and more constructs as antecedents of a construct which you want to explain or the like. But then if you put in more and more and more, then the theory gets very complex. You don't see the essence anymore. It might be better in explanatory power, but it loses parsimony. That's not good either. So you want to have a parsimonious theory, one which comes along with few constructs, few relationships. Next we have nomological validity. Constructs should make sense in the context of other constructs they relate to. Constructs describe what we're actually interested in, not just anything which we're not interested in, and not just anything which is totally unrelated to everything else we know. So you embed it in a nomological net, in a network of relationships among other known and interesting constructs. Then research should be generalizable. The more generalizable it is, the higher the quality. Although there's some value in domain-specific, context-specific theories as well. Conclusions can be drawn with respect to other sets of observations, and only conclusions that are logically supported are drawn based on the sample. But then if you exchange the sample and the same conclusions hold true for another sample, then the theory has a higher level of generalizability, it has wider boundary conditions, it has a broader scope than if it wouldn't be generalizable. And finally here we have utility as a quality criterion. The theory should be relevant to practitioners. You should have unique findings in what you contribute to the body of knowledge. Now, I said before, This is a set of important quality criteria, but it's not a comprehensive set. Depending on the specific domain you're in, the specific methodology you're using, and so on, there are many more detailed quality criteria to look out for. But rather than moving on with quality criteria, let's briefly consider a few common mistakes done in research. One would be insufficiently motivating your research question. So the questions are, what is interesting for us? Is it also interesting for society? It's not worth pursuing everything which is not known yet. You need to see what is the value of it for others. Is it really interesting to pursue that? Or has it just never been done because it's just not interesting? So not every research gap should be closed. It should only be closed if it's interesting, and not only interesting to you, but at best also to others with whom you want to engage in a conversation, whom you want to influence with your results. Then another common mistake is pursuing research fads. So hot topics, especially if you look out at real-world phenomena and what the press and social media and so on hype as hot topics, well, that's interesting, that's new, that's unknown, there are research gaps. But on the other hand, they might fade quickly. So it's better to prefer timeless topics, somewhat timeless topics, but not fully timeless topics, because then you're missing the trends and the interesting things. So as you see, there's a trade-off between interestingness and pursuing research fads, but you shouldn't be too much focused on hot topics, because these fads might die out before publication of your paper. Then there are unresearchable problems. Answering a problem appropriately might just be impossible, or the observed evidence alone might not be enough. So not every research problem can be solved, and you should pick problems which you can solve. Then the next common mistake is to always go for your favorite research methods. Research methods should be chosen to best fit a research problem, not the other way around. So typically you should start with a research problem and then pick the best method, rather than saying, I'm an expert for this method and I only look out for research problems which fit this method. I mean, the latter is still better than having a misfit between research question and research method. That's a total no-go. But the way more interesting way to contribute to scientific knowledge is starting with the interesting and relevant research problem and then picking the method rather than the other way around. Finally, the last common mistake I want to mention here is the blind data mining. So, for example, when data has not been collected carefully, garbage in, garbage out, then you can't draw much of a conclusion from the data. And you shouldn't only collect data and then mine it and mine it and mine it until you find some significant effect anywhere, because significant effect tells you that it's unlikely that this effect occurs by chance, but this unlikeliness, the significance level, the p-value, and refers to statistical hypothesis setting, when you have an ex-ante theoretical hypothesis and then test it in the data. If you just crunch the numbers in any way which is possible, then you'll find many statistically significant results, but this is meaningless because it's purely exploratory data mining, and you shouldn't do that. You should have a clear theoretical perspective up front and then develop your data collection in a way that you have high quality data for you really testing your statistical hypotheses.